Let's be real. Prepping for technical interviews can feel like a whole other full-time job. But what if you could slash your data structures and algorithms study time, just by picking the right resources in the right order? Well, today, we're going to build an incredibly high-impact study plan, and we're going to do it using a tiny but powerful algorithm.
If you've ever even tried to start studying for DSA, you know this feeling. It's like you're immediately hit by a tidal wave of resources, and you have absolutely no idea where to even begin.
I mean, look at this. You've got the classic, massive textbooks, you've got endless video courses, dozens of different practice platforms, blogs, articles. The list just keeps going. It's a total resource maze, and wandering through it without a map is a recipe for burning out before you even get to the really tough problems.
But here's a thought. What if we could use the very subject we're trying to learn to solve this problem? What if we actually used an algorithm to build our learning plan? Okay, let's dive into this, because this is a really cool way to bring some order to the chaos. So we are going to frame our study plan as a classic computer science problem. Welcome to what we'll call your study knapsack. This is all about how to think like an algorithm to learn algorithms. Now, for anyone who needs a quick refresher, the knapsack problem is this famous optimization puzzle. The goal is super simple. You have a bag, a knapsack, with a limited weight capacity. You also have a bunch of items, and each one has its own weight and its own value. Your job is to pick the combination of items that gives you the absolute highest total value without, breaking your bag. And this is a brilliant metaphor for our situation, right? Your study time, whether you've got 50 hours or 200 hours to spare, that's your knapsack. It has a fixed capacity. And all those books, courses, and problem sets, those are the items. Our goal here is to pack this knapsack to completely maximize our learning value.
So, before we can start packing, we need to know what items are even available. Let's take a look at a curated toolkit of some of the best resources you can put into your study knapsack.
A smart plan uses a mix of resources, and each one has a very specific job. Think of it like this. Books like the classic CLRS or Skina's Algorithm Design Manual, those for deep, foundational understanding. Then you have courses from places like MIT or Princeton, which offer fantastic conceptual clarity. Platforms like LeetCode and Codeforces are where you get your hands dirty with deliberate practice. And finally, references like Visualgo are perfect for those quick lookups when you just need to build some intuition. A truly great plan balances all of these.
All right, we have our knapsack and we have our items. Now for the really smart part, the algorithm that's going to decide what actually goes into our plan. It's a pretty straightforward 4-step process. First, for every single resource, you estimate 2 things: the hours it'll take you and its personal value to you. Now, value here is totally subjective. Is it a topic you're weak in? Is it a course with amazing explanations? That's your call. Second, you score each item. This is basically its value per hour. You might also adjust this score a little. A resource that's a perfect match for where you are right now gets a small boost, while something way too advanced gets a penalty. Third, you sort all your resources from the highest score down to the lowest. And finally, you pack your knapsack. Just start adding items from the top of that sorted list into your plan until you run out of time. Simple as that.
So what we're doing here has a name. It's called a greedy heuristic. We're always picking the best available option at each step. It's incredibly fast to run. Really, the sorting step is the only thing that takes any time, making it O(n) log n, and most importantly, it's simple and easy to explain. You'll always know exactly why a certain resource made it into your plan.
Now I know what some of you might be thinking, but wait, a greedy algorithm isn't always optimal for the knapsack problem. And you know what? You're absolutely right. There are more complex algorithms, like dynamic programming, that could find the perfect 100% optimal plan, but they're so much slower and way more complicated. And since our value and hours are just good estimates to start with, this fast, simple, and super effective greedy approach is just the smarter, more pragmatic choice here.
Okay, we've got the theory, we've got the algorithm. Now let's translate this into a real action plan by looking at some common study pitfalls that you absolutely have to avoid. These are the rules to live by. Rule 1, don't just grind problems endlessly. The real learning happens when you study the explanations and editorials. Rule 2, avoid gold plating, which is trying to learn all the theory before you do any practice. Mix them together from day 1. Rule 3, focus on deeply understanding the fundamentals, don't just memorize patterns. Rule 4, keep your code clean. Seriously, implementation hygiene matters in an interview. And finally, and this one is huge, practice explaining your solutions out loud. An interview is a communication challenge, not just a coding test. If you take just one thing away today, let it be this. The goal is always a balanced plan. It's about combining fundamentals with practice, with regular checkpoints to make sure you're actually on track. Quality and consistency will always beat raw volume.
So there you have it, the framework to build a smarter, more efficient DSA study plan. The only question left is the one that really matters. Using this method, what's going to be the very first item that you pack into your knapsack?